Hello ladies and gentlemen, I am Dylan Hamilton from C.A.R. Entertainment, and today we are going to be talking about A22 biology, but this time we are going to be talking about chloroplasts and two people who perform different experiments on chloroplasts. And we'll get straight into it. It's going to be quite a short video, but it is quite a nice one if it comes up. So you have Engelmann, who was around the 1880s, and he wanted to find out how photosynthesis used light from the blue and red parts of the absorption spectrum. So he used this thing called Alga spirogyra, and it had chloroplast remains in a spiral pattern. He then used mobile aerobic bacteria as it was likely to cluster in oxygen-rich regions of the chloroplast. So he then passed the light through the prisms onto the spirogyra in the presence of this aerobic bacteria. This bacteria then clustered very close to the chloroplasts in this Alga spirogyra, and it received blue and red light. So he came to the conclusion that bacteria accumulated in greater numbers around chloroplasts that synthesized at fastest rates and produced the most oxygen. So I'll say that once more. So he concluded that bacteria accumulated in greater numbers in chloroplasts that were photosynthesizing at faster rates, and we know that photosynthesis occurs at a faster rate through blue and red light according to the absorption spectrum. But he also concluded that bacteria accumulated in greater numbers around chloroplasts that produced the most oxygen. So cells in chloroplasts in the red and blue light cells of chloroplasts that were in red and blue light photosynthesize at the fastest rates. That's essentially what he concluded. Then you have a Mr. Man called Kelvin, and he made an experiment that was referred to as the lollipop experiment, where he added carbon dioxide to a suspension of autotrophic protoctistins called chlorella. So he added CO2 to a suspension of autotrophic protoctistins called chlorella, where he then had a short interval between each, and he opened a tap. So the chlorella would be released into hot methanol, where it would be killed immediately, and any further reactions would be prevented. Next, the chlorella was homogenized, and the compounds present were identified by chromatography. So any compound that contained radioactive carbon that was produced following the fixing of carbon dioxide in the light independent stage, you then seen that pop up. So as you gradually increase the time interval, you would identify compounds that were produced at the successive stage of the light independent stage, and therefore this is how you're able to determine what's produced where. So yeah, like I said, very, very short, but that's all you really need to know in terms of the chloroplast. I'll be Dylan Hamilton from C.A.R. Entertainment, and I will see you next time.